Now for a new type of problem. Another type of problem that tends to be slightly trickier for our students are these mixture problems. When you are combining two things that are similar, maybe with different concentrations, maybe with different interests, and you are trying to come up with a final result, a very specific final result. So as you are reading this question, I'm going to get ready to indicate where our variables are going to lie. Now luckily we have a handy dandy little question mark here. So I'm going to start at the phrase that has the question mark. How many ounces of each solution should he mix together? So that tells me I need to be looking at my solutions to figure out what my two variables are. I like purple. We know we want to know how many ounces of each solution, and the two types of solution that we have are a 20% poison solution and a 50% poison solution. So again, you're going to be tempted to take shortcuts here. Please do not. With our variables, I don't have any very good descriptor for these variables, so I can use x and y. I'm going to allow x to be, okay, very carefully, ounces, or specifically number of ounces of, let's say, the 20% poison solution. Now, I don't need to write my ounces because they're here. Those are the units that I have. Ounces, somehow. Anyway, you know what that says. And y is going to be the number of ounces of the 50% poison solution. With my equations, I'm going to have two different types of equations here because I have two different ounce quantities that I'm going to measure. I adjusted. I apologize for the swinging of the screen there. My equations are going to be total solution and poison. Those are going to be the two equations that I have. So let me ask you this. How many ounces are in our total solution? If you read the problem, it's going to tell you he needs 6 ounces to kill Vicini. So I know 6 ounces needs to be my total. But how am I going to come up with those 6 ounces? I'm going to add bits of my two solutions, them being x and y. So if I add number of ounces of the 20% solution and number of ounces of the 50% solution, I should get my 6 total ounces needed to kill Vicini. So then what about the poison? With the poison, I'm actually going to start using my percents. So first of all, I can't use percents as percents. I have to turn them into decimals. But my poison solution is going to talk about how many ounces of poison are in each solution that I have. So the number of ounces of poison in my X solution is 20% of it. 20% of my X solution is poison. And 50% of my Y solution is poison. And that's going to give me the total poison in my final solution. And I know that I've got 6 ounces of my final solution, and I need it to be 30% poison. So these types of equations are going to have your two variables equal your total, and then each percent times its respective variable will give you the percent of the total. Those are going to be the two equations that you get. Well, now we're ready to solve. I'm going to write out my two equations again. I've got x plus y equals 6. I've got 0.2x plus 0.5y equals, and I could do this in my calculator, 0.3 times 6. In fact, we will in the next step. Actually, let me pause and I'll do that now. Where's my handy dandy? Okay, now I'm a little embarrassed. 0.3 times 6 is 1.8. I knew that. Really, I did. And again, I need to justify which method I'm going to use to solve. But if I look at this equation, I can see that substitution is a nice choice. Why, you ask? Because I have coefficients of 1. If I don't see any number written in front of my variable, it's the nice one to isolate. So let's isolate x. If we isolate x, I get x equals 6 minus y. And this is what I'm going to plug in for this x. So 0.2 times 6 minus y plus 0.5y equals 1.8. 0.2 times 6 is going to give me 1.2 minus 0.2y plus 0.5y equals 1.8. If I combine these two, I get a 0.3y. Subtract the 1.2 over, I get a 0.6, so y equals 2. Divide. Now with this y equals 2 value, I'm going to plug that back into my other equation. X plus y equals 6. X plus 2 equals 6, so x must equal 4. And then if I check this, plug it into the other equation, I'm going to see that 0.2 times 4 plus 0.5 times 2 should equal 1.8. 0.2 times 4 is 0.8. 0.5 times 2 is 1, and when I add those together I get 1.8. We're good to go. But we are not allowed to forget this last step, which is, of course, to write our sentence. So, the man in black needs 2 ounces of the, now be careful which solution went with y. That's my 50% solution. Oop, too far. Of the 50% poison solution, and 4 ounces of the 20% solution to kill the seamy. Okay, I didn't need all of those words, but I liked them. I'll need more, but I suppose. Alright, I want to check the time. I think we probably have time for another one. We do. I would like to do another mixture problem. So, we are going to go to the next slide. I'm going to see if I can get the red lines off the screen just by rotating and rotating back again. Oh, I think I see what happened here. That's interesting. Actually, I'm going to stop because I don't know how much of that you saw.